Now we're going to look at some tighter definitions of what sine, cosine and tangent are, using the coordinates of a point on a unit circle. So a unit circle is something sort of a creation by a mathematician, something that doesn't really exist in the excuse me, the real world. Unit circle because the radius is unit 1, unitless. Now it's plotted out against x and y. So normally if you're trying to find the position in x and y, this is P, we're actually going to try and work it out in terms of an angle. So this angle theta in here, so obviously as theta gets bigger, x and y are going to change as that point moves around the circle. So it's a bit of a sleight of hand, but what mathematicians say is if I want to find the length here of y in terms of the angle theta, I'm just going to say that y is the sine. Let me just switch pins so they stay. Y is the sine of theta. And also, if you want to find out what the x is the cosine of theta. So it's a bit of a trick because they haven't really said what sine and cosine is, but you take that as a given that at some point you'll be able to relate sine and cosine to an angle, and your calculator does a very good job of that. The third trigonometric function, let's get the diagram of that, is tangent, which is a little trickier to explain. Just grab that, scroll down a bit. Alright, so again, the fictitious unit circle. There we go. So, as before, we've got the sine and cosine, but you could also have a tangent at this point. Tangent means it just touches the circle along this line. And again, good old mathematicians say this distance here we're just going to call tan of theta. So that's all very well, but how does tan theta relate back to the sine and cosine that we've just been looking at? Well, it's done through similar triangles. If you look at that triangle there and that triangle there, they're similar. Now, what that means is that in terms of the ratios of that and that and that, and let's get this right now, and that. Now, noting here, this distance is 1 because it's a unit circle, and that distance is tan. You can write that out by similar triangles to say that the sine of theta there over the cosine of theta there is the same as tan of theta, because they're in the same ratio, over that distance there, which is 1. Or rearranging slightly, just writing tan on its own, sorry, is equal to sine of theta over cos of theta. So this then relates sine, cosine and tangent. So when we're looking to solve triangles, we've got the tools. As long as we've got a right angle triangle, an angle and one side, we'll be able to solve for the other side, or if we don't know the angle, we can solve for the angle if we've got two sides.